In the lessons leading up to this lesson, you've learned a lot about the different groups of elements on the periodic table, the different chemical characteristics that make the elements within those groups similar to one another, but characteristically different from the other groups on the periodic table. You've also learned that the characteristics of those elements in those groups have to do mainly with the placement of the electrons around the outside of the atom within each of those groups. In this lesson, we're going to learn about a different kind of group of element on the periodic table as we learn about one that doesn't depend on the electrons so much as what's in the nucleus. In this lesson, we're going to be learning about the radioactive elements on the periodic table of elements. Now, the radioactive elements are located across all of the different groups of elements. The only one that doesn't have a true radioactive element in it is the fairly reactive nonmetals, and that's only because the fairly reactive nonmetals is so high up on the periodic table, whereas all of the other groups go way down to the bottom. Here's where the radioactive elements are located. Now, to be honest, any element on the periodic table is capable of being radioactive. Even hydrogen, which is element number 1 on the periodic table, the lightest element of all, has the simplest nucleus ever, can be radioactive if it has 2 neutrons and 1 proton in its nucleus, an imbalance of protons and neutrons. Remember, that's what causes radioactivity. So all elements on the periodic table can be radioactive, but what sets the radioactive elements apart as their own group is that any time that they're found anywhere, every single isotope of these elements is always radioactive. There are no stable isotopes of these elements. Now you'll notice that one of these elements is in a really weird spot. That element is technetium, and it is the only lighter element that is all radioactive, all isotopes, all the time. And then the other element I'm going to pull out is in the very, very bottom row of that very bottom section of the periodic table. That's the element uranium. Now, when you look at these two elements, you maybe notice that they don't have a whole lot in common. Radioactive elements can be found in any group of the periodic table. That means they can have 1, 2, 3, 4, 5, all the way up to 8 electrons in their outer shell. It's possible for them to be from any chemical group of the periodic table. The other thing that's true about the radioactive elements is that they have an imbalance of protons and neutrons. Now, these two facts have something very important in common. You can't see either of these just by looking at a picture of the atom. You can't see necessarily for sure which group it's in, and you definitely can't tell whether the protons and neutrons are imbalanced unless you're an atomic physicist and you study that sort of thing. But the last characteristic is something that can be observed, and that is that the radioactive elements tend to have a whole bunch of protons and neutrons. The lightest radioactive element, technetium, which is significantly lighter than all of the other radioactive elements, has 43 protons and 56 neutrons in its nucleus. And there is no combination of protons and neutrons that makes technetium balanced. It's a strange element in that way. Most radioactive elements have way more protons and neutrons than even that. For instance, uranium, which is the last radioactive element that can actually be found in nature, all of the radioactive elements past uranium are ones that are synthetic. We have to make them in a lab if they exist at all. Uranium has 92 protons and 146 neutrons in its nucleus. And as you look at that atom, you see there's a lot going on there. It's got a huge nucleus, a lot of electrons. That nucleus is very difficult, in fact, impossible to balance because it's so big. So that's what makes the radioactive elements appear at the bottom of the periodic table, because those are the heaviest elements, the ones with the most protons and neutrons. And when you have too many protons and neutrons, it is impossible to balance them in the atom. Therefore, the atoms will break apart. Characteristics of the radioactive elements are things that we've learned about before. You know that they spontaneously break apart to make different atoms than the original atoms that were there. an element of radon, which is a noble gas, a substance that is completely unreactive and a gas at room temperature, will radioactively break down and become lead, a metal. That's what the radioactive elements do. They can change from one type of element to a completely different type of element because the number of protons is changing and they're changing their identity. Other characteristics, they completely change, completely from one type of atom to another. When radon changes to lead, there's nothing radon-like about it anymore. It is completely a different element in a different group of the periodic table. And then finally, as they break apart, they release radioactive particles or radioactive energy. Those things that we talked about in Unit 6, alpha particles, beta particles, neutrons, or gamma rays. All of these things can be released when radioactive particles break apart. So now you know about the radioactive group of elements on the periodic table. Most of that group is located way at the bottom, and it consists of atoms that are not stable, and the nuclei will break apart, changing them to different atoms.